Good morning, dear students. So this is a video of class 11, and in this video we are going to talk about the properties of dihydrogen. As you know that dihydrogen means H2, okay na? H2, and in this one we will discuss about all that properties. Okay, physical properties we will talk about. Dihydrogen is a colorless. Okay, it does not have any color. Okay, it has it is orderless. ODOURLESS. Orderless means no smell would be there. Tasteless, no taste. And this one is the combustible gas, means if one this is actually combustible, means which will burn, okay na, which will burn completely. And also it is lighter than air. The density of the dihydrogen is lighter than air. Okay, because you know air is a mixture of many gases. Okay, but hydrogen alone is lighter in weight as compared to air. And it is also insoluble in water, because you know that if I will write H2O, it is a mixture of hydrogen and oxygen, and in 1 is to 8 ratio, and in the volume 2 is to 1 volume. So excessive amount of hydrogen cannot mix into the water. So we can say it is insoluble in water. More amount of hydrogen will not mix, as the volume and the mass is fixed. So more amount of we that hydrogen we cannot mix into that one. Okay, na? So this one is these are the physical properties of the dihydrogen. Okay, you can see the very first physical property, that dihydrogen is a colorless. Then after this one is odorless, or D would be there here, D. Okay na? Then after tasteless, combustible gas, and it is lighter than air, insoluble in water. Okay, then after the chemical properties. Okay, this is a very important thing, that dihydrogen actually accomplishes reactions by losing of electron. If it will lose the electron, it will form H positive. It can gain also one electron. If it will gain one electron, then hydride formation would be there, and then sharing of electron would be also there. So then after it forms single covalent bond. So this is one of the property of the hydrogen, we can say the best property of hydrogen, we can say. It can form H plus also, it can form H minus also, it can share its bond also. That means single bond formation. Okay, dear student, so this is important thing about the hydrogen. Huh? Only one hydrogen can form these all H positive, negative bond. Okay, reaction with halogens. So if you will take H2, dihydrogen is H2. So here I am going to show you reaction with halogen. So H2 and halogen is plus Cl2, and what it will form? It will form 2HCl. 2HCl. So reaction with halogen you have seen. Reaction with dioxygen, yeah, this is very simple. H2 plus dioxygen, O2, and it will form H2O. Okay, so this one is the slides, and we will discuss some of the more chemical properties on the board. Okay, please wait. Okay, so here we are actually discussing about the reactions of hydrogen with different molecules. Okay, now in the very first reaction we are talking about the Born-Haber process. Born-Haber process is a reaction between dihydrogen and nitrogen, and in this one, at 673 Kelvin, it actually produces ammonia. So we will see the reaction between reaction between hydrogen with nitrogen. Okay, na? And this one is reaction, you can write in short. I used to write this one between, okay, reaction between hydrogen with nitrogen in a Born-Haber process. Okay, na? So it will H2 plus N2, it will give ammonia you can balance that one. 2NH3, 2 3 is 6, so 3H2. And here you can see this one actually work at 673 Kelvin. Okay, and the temperature is, and the atmospheric pressure is 200 atmospheric pressure, and the catalyst would be iron. In an iron furnace, when we will take the hydrogen and the nitrogen, then it will give ammonia. Okay, next one, this one was the first one. Second reaction between hydrogen with metal. If any of the metals are there, then these metals, if any of the metal, if I will take, and when it will react with the hydrogen, it will actually form a reaction between metals and hydrogen. Okay now, so here you can see M I have taken. M is for metal, common. Okay, H2 I have taken. Then after it will form MH, only MH. Okay now, here you can balance that one, 2MH. Okay now, if I have taken Ca instead of metal, I have taken Ca plus H2. What it will form? 2CaH. Here 2Ca has 2 positive, and this one is 1 negative, so 2 into 1 negative, and this one will give you 2 negative. Okay now, so Ca 2 positive, 2 negative. No, there would be the problem. CH2 you have to form. Okay now, CH2, Ca 2 positive, and then H2 1 negative into 2, that one is Ca 2 positive, and this one H is 2 negative, and that one will give you that balancing CH2. Okay now, if I am taking Na plus H2, what it will form? Here I have to take this one 2, so it will form 2NaH. Okay, one positive, one negative. So this one is a balanced chemical equation. Positive and negative should be balanced. Okay, in the next reaction we will actually take the metal ions and the reaction of metal ions with hydrogen. The reaction of metal ions with hydrogen. Okay now, so here I have taken metal ions, any of the metal ions, so I have taken metal, Pd, palladium. Okay now, Pd 2 positive, and I have reacted with hydrogen. As you know that hydrogen here in the neutral state, its oxidation state would be 0, its oxidation state would be +2. Okay, so what will happen when this hydrogen is react with Pd2 positive? Its oxidizing agent capacity will increase. This hydrogen will become as a positive oxidation state, and this one will reduce to give Pd, means 0 oxidation rate. So this H2 is actually used as a reducing agent. So what it will form? Pd2H plus. Okay, so you can see this one reaction of dihydrogen, I can say, right, dihydrogen with olefins. I can write olefins means the organic compound which contains double bond, carbon compound which contains double bond. Okay na? So I can write here ethene is also olefin compound. So here I will take CH2 double bond, CH2 plus H2. Okay na? So one H I can write like this one, and you know this can break. Okay, one electron will go on to this one electron will go on to this one hydrogen can come on this one, and one hydrogen will come on this one. So symmetrical representation we have discussed in this class also. So what it will form? CH2, one hydrogen will come, so CH2 one hydrogen I can write, so together it can be written CH3, and this single bond CH2, one more hydrogen, so CH3. This is the structure. Okay, so you can see that with various example we all will discuss this one into the class, but I will tell you that more of the ions you can take: Pd2 positive, Mg2 positive, Pb2 positive plus H2. H2 will always act as a reducing agent and reduce its oxidation state. Okay, this Pd2 positive, you can see Pd2 positive initially 2 positive, now it is changing into 0, so oxidation state is decreasing. Here 0 and here plus 2, so oxidation state of hydrogen is increasing. In this case you can see double bond is actually breaking with the addition of dihydrogen. So this is also you have to understand. Okay, na? Various example we can take, we will discuss this into the class. Thank you.